Very good morning, students. So very good morning, students. Welcome to prestigious IIT and NEET Foundation, our Focus C program of Krishnaveni Talent Schools and the Mastermind Schools. So welcome back you all after the term 1 vacations. So happy to see the branches joining for the today's session. So as you all well know, and you can see on the screen, so my subject is physics. We are in class 6th. Today we are starting a new chapter, the unit 3, chapter number 3, that is laws of motion. And today we are in the session number 1. After completing the 2 chapters, that is measurement, we completed, and motion we completed. Now we are entering into the laws of motion. That is a continuation of motion, which is observed out of anxiety. When you came to know about the motions, different type of motions, the many scientists of that days, ancient days, they are very anxious to know what is the reason behind the motion. Why bodies are moving motion, right? So we learn only about the motion and various types of motions, which we can see in our day-to-day life. But we are not discussed about what is the reason behind the motion. That is, while studying about or by knowing about the reason behind the motion, Sir Isaac Newton is observed or find out a perfect reason for motion of a body. And that leads to propose 3 important laws related to motion of a body. And those 3 laws together are called Newton's laws of motion. So we are going to discuss about 3 important laws of the motions, and regarding that, what new terms are discovered by Newton and how these laws are applicable in our day-to-day life, right? So next coming 3 to 4 classes, we are going to discuss about all the 3 important laws of the motion, which are very important in our day-to-day life, right? So in that process, already I told you, so this is called the first part. When you come to synopsis 1 from your material, first we discuss about the Newton's first law, right? So what are this Newton's first law? So because already I told, these laws are over anxiety of reason behind motion. So why body is moving? Many scientists have made attempt to know about the reason behind the motion. Cause behind the motion, you can call it as, or cause. What is the cause of motion? While knowing about that, they came to know that there is an important word called force, right? So the word force comes into act. While knowing about that force, what happened when the force is applied on a body? What happened when force is not applied on a body? In both cases, they studied and compared by the Newton, and it proposed 3 important laws regarding the motion of a body, right? So you can see here, Newton has given 3 laws to describe the motion of a body as well as cause of motion. These laws known as Newton's laws of motion. Clear? So 3 laws which are proposed by Newton to describe the motion of a body are called Newton's laws. In that, if you see the Newton's first law, today we'll discuss about the Newton's first law. Very important. Observe carefully. This you can see. Anytime you can do the practical for this. There is nothing is required for this. If no external force is acted, if no external force is acted, a body continues to be in its state of rest or uniform motion along a straight line. Try to understand. If no force is applied, body may be either at rest or uniform motion. For example, see, place one book on table. So leave it there for some time without applying any force, external force. Will it move? No. Book does not move unless you apply the force. Similarly, you are going by cycle. You are riding cycle. If you are not applying the pedals, body will go with the, cycle will go with the only uniform. Unless you apply the pedals, we cannot increase the speed. Or unless you apply the brakes, we cannot decrease the speed. So either body is continuously in the state of rest or uniform motion until acted upon by an external force. Right? That is the first law. See, again, second also given. If no external force acts, we can also say that bodies go on doing what they are doing. What they are doing, it will look. But if you apply the force, either it may come to rest or it may start moving. Simply you are sitting in a car. Can it move? No. We have to apply force. We have to start the engine. You are moving with a great speed. Somebody came in the path of you. Will it stop automatically? No. You have to apply the force. Either body is at rest or in uniform motion. It is continue to be in the same state until an external force is applied. That is called Newton's first observation. That is called Newton's first law of motion. Newton's first law of motion. Okay. Called Newton's first law of motion. Okay. Why? So this can be observed everywhere. Every example in our day-to-day life is explains this. Correct or not? So unless you apply a force, neither you can move from rest to motion or you can come from motion to rest. So that is the first law statement given by the Newton. And what is the property of the body? That is not why it is not happening, because that is having some internal property of the body called inertia. The property of the body which cannot change its position itself until force is applied is called inertia. So Newton's first law gave a birth to a new word called inertia. So because of inertia only, Newton's first law is defined. That's why Newton's first law is also called law of inertia. What you can call? Law of inertia. What is inertia? It is an internal property. Inherent, you can call it as inherent property. Inherent is nothing but internal. Inherent property means hidden. Right? Hidden property of the body by which it cannot change its position. Suppose you are sitting now. You are sitting on a table. Until you apply the force, you cannot move. Simply sitting like that, you cannot go to home. What do you have to do? You have to apply some force to get up and you have to apply some force to walk. Why? Suppose you want to take the turn from the cycle or vehicle, you have to apply some force. You want to start from rest to motion or motion to rest. What do you have to do? You have to apply the force. Until unless you apply the force, we cannot change any position, any state. Such property of a body, such inherent property, such an internal property of the body is called inertia. So Newton's first law gave birth to the word called inertia. What is inertia? An inherent property of a body with which body is continuous to be in the state of rest or uniform motion until an external force is applied. Either it may be moving in straight line, it will continue to be in straight line only. It is moving the other path, it goes in same path. It is going in circular motion, you go on the circular motion only until you apply the force. If it is at rest, it is at rest only. Such an inherent property, such an internal property of a body is called inertia. Right? Clear? So that is first law is defined the word. So in the above law, it is clear that body is at rest and body is in uniform motion continue to do what they are doing. Thus, a body cannot change its state of rest or uniform motion by itself. It cannot change by itself. It can change only by applying the force. Such a property is called inertia. So, the definition is given. The inability. Inability means ability is nothing but can do. Inability is cannot do, cannot change. The inability of a body to change by itself, its state of rest or uniform motion is called inertia of a body. Or inertia can be defined, also defined as tendency of a body to remain in the state of rest or uniform motion. Either tendency you can say or inability. So no body can change from rest to motion or motion to rest or direction until an external force is applied. Such a property is called inertia and such statement is called law of inertia. That is Newton's first law of motion. Right? So the inertia can be either it is applicable on a body at rest, it applied on body and motion, it can apply on the body when it is in direction, changing the direction. In all the cases, we'll come across this property of inertia, right? So there are different types of inertias are there. We'll see. So you can see here, measure of inertia. How to measure inertia? Mass is the measure of inertia. Means inertia depends mainly on mass of the body. Greater the mass, greater the inertia. Suppose you are only 30 kg and your friend is 50 kg. Another friend is 80 kg. So different people will have different inertia. Based on their application of force, either they can move or they can stop. For moving also require more force, the person is those heavy and less others. So it is the most difficult move a heavy body than lighter body. Common. There are two bodies are there, heavy and lighter. So we can move the lighter body very easily when compared to the heavy body. So that clearly indicates that inertia depends on mass of a body. Thus, the more the mass, more the inability of the body change their state and hence more their inertia. So hence we can conclude that mass is the measure of inertia. Very important point. What? Mass is the measure of inertia. So this point is very important. Right? So this is Newton's first law. You can note down first point number 1. And the next one is about the inertia. We can write down this second point number 2 from here to here. And third point is about the measure of inertia. Right. So open your notebooks and write the point very fast. So Newton's first law is the heading. If no external force acts on a body, it is continuous to be in its state of motion along a straight line. Up to here you can write enough. The second one is same answer. Right. First point. Second point is about the inertia, the inability of the body. Right. Up to here you can write. And third one is mass is the measure of inertia. Please make it fast. Write down these 3 points as synopsis 1. You can see clearly, right? So there is no complications. First point, Newton's first law heading. If no external force acts on a body, a body is continuously Right. The second point you can note. As a third point also. 3 points you can note from this. Nice. So what you observe here is unless force is applied, no body can change its state. If it is at rest, it will be at rest only. If it is in motion, it is motion only. If it is moving in straight line, this continue to be in straight line. Right? So point number 1, point number 2 about inertia, point number 3 about the measure of inertia. Okay. Oh. So then we are saying that we are having the inability to change our position. Then what to do? Suppose you are sitting one place, you want to move. How will you move? How will you move? What is the okay? How you move? So we need the force. That is the cause. So cause of overcoming the inertia is force. So that is the next part we are discuss. What cause is the force. After knowing about the inertia, now the same scientists started studying about the force. Means if you want to overcome the inertia, what we need here? Force. So force is the cause to overcome. Force is the cause to overcome the inertia. So what completed? I didn't understood. Sharat Kumar. Okay. Good. So what is the cause is? So we have seen that inertia is defined as inability of the body to change itself from rest or uniform motion. Then how can body overcome the inability? So that inability is overcome by the force, right? So force is the responsible for overcoming the inability. Okay, Varasi Guda of the video. So what is force? So here given. So force may be that physical cause which change. So note this fourth point. Fourth point as force. Force may be defined as physical cause which changes or tend to change the state of rest or state of motion of a body. So how to change the body from rest to motion or motion to rest is force. So the definition of force you can note on last two lines. Note down the last two lines which defines the force. So force is the one which changes or tend to change, means try to change. Tend is nothing but try. Try to change the position of a body either from rest to motion or motion to rest or changes the direction. Okay, that is called force. So note the fourth point as a force. So force may be defined as that physical cause which changes or tends to changes the state of rest or state of motion of a body. So point number 4. After writing this, I'll show you one video regarding the Newton's first law. After that, we go for the types of inertias to complete the Newton's first law, right? First, write on the point. Last two lines. That is the definition of force. Definition of force, right? Okay. So just keep watching the video on the Newton's first law of motion. Okay, just watch.
Imagine you're sitting on a recliner chair watching your favorite movie on a lazy Sunday. And your mom calls out your name and asks you to run some errands. You can imagine how difficult it would be for you to get up and do the work. Imagine you're practicing for your 100 meters race on this track. And somebody asks you to stop immediately within a second. Will you be able to do it? What if you're suddenly asked to turn towards the right? Will you be able to turn immediately? The answer to both the questions would be a no. You can stop, yes, but gradually. You can also turn, but not sharply. And guess what? It's the same story with every object. Every object will continue to do what it's doing. If it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But what can change this? Yes, only an unbalanced force can change this. If it's at rest and an unbalanced force acts on it, it will move. If it's in constant motion and an unbalanced force acts on it, it may accelerate or change direction. And this is nothing but the Newton's first law of motion. Here's the correct definition. An object at rest stays at rest, and an object in motion stays in motion with the same speed and the same direction, unless acted upon by an unbalanced force.
Right.
In simple words, it means that the objects continue to do what they're doing unless some external unbalanced force acts on them. We can also understand this using a simple diagram. If the forces are balanced, there can be two cases. An object may be at rest, or an object will be in motion at a non-zero constant velocity in a particular direction. These can be the only two cases when the forces are balanced. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction. Don't forget, these two cases will remain true.
Right. So this is the one case. So you can see
Amazing research laboratory that's orbiting the Earth about 250 miles above us. While we're at the space station, we astronauts live and work in a microgravity environment. Do you think the laws of physics will hold up in the space station while experiencing microgravity? Let's check with NASA astronaut Mark Vande Hei on the International Space Station to find out.
Newton's first law of motion says an object at rest tends to stay at rest unless acted on by an outside force. Also, an object in motion tends to stay in motion unless acted on.
Let me. Okay. So what explained here clearly is, body it will do what it is doing continuously until an external force is applied. Either you want to move body from rest to motion or motion to rest, you need to apply a force. So force is the cause of motion, right? So while studying about this, a word called inertia is introduced, which is the inability of the body to change its position. Suppose when you are running very speed, if somebody asks you to stop, we cannot stop suddenly. It will take some time to stop. Or if you want to change the direction, you need to take some time to change the direction. We cannot change the direction suddenly because our body need to act upon by a force to change the direction or to come from motion to rest or rest to motion. Right? So 4 important points we learn from the first slide. Right? Then this inertia we can see in the various examples. So different ways you can see the types of inertia. So there are 2 types are there. Inertia at rest inertia of direction. So suppose, or inertia of motion you can call it as. So inertia of motion, inertia of direction. Suppose, example I'll tell. One simple example. You are sitting in a bus which is at rest, right? You are sitting in a bus. You are also rest with bus. When bus just starts suddenly, what happens? You will feel jerk. You will feel jerk. Suddenly you will feel jerk like this. Will fall front. Why? Because as your body is at rest, to move from rest to motion, it needs some force. If you not apply the force, you will fall down. You will hit to the front seat. Correct or not? Simple logic. So move from rest to motion, we need some force, and that inertia is called inertia at rest. Right? You can see so many examples are given in your material also. We'll discuss. So first one is inertia rest. The tendency of the body to continue in the state of rest is called inertia of rest. See examples given. The passenger standing in a bus fall backwards when the bus suddenly starts, because the feet of the passenger starts moving along with the bus as it is contact with the floor of the bus, whereas the upper part of the body where you are standing, right? So inertia of the rest tries to remain the stationary. Thus, the lower portion of the foot moves forward and then upper portion remains rest due to inertia of rest, and the fall backwards. When a paper on which a pile of books are placed, you can see here, and suddenly pulled, you can see you take one glass, place the paper on that, and place one coin over the paper or sheet of paper. You pull the paper, the coin will fall there only. It won't come fall. You might have seen so many examples, right? So that is because of the inertia of rest. Then inertia of motion. Suppose a bus is moving with great speed. Suddenly, speed breaker comes. Apply the brakes. Then we feel forward. Jerk will come forward direction. Means because you are in motion, from motion to rest, if you want to come, you have to apply some force on your body so that no problem. Seating part is okay. Down lower part is rest only. But upper part is in motion with bus. So we need to apply some force to avoid the accident or damage. So many examples you can give. Suppose when you switch off the fan is moving with a great speed. Switch off the fan, it cannot stop immediately. It will take some time to comes to rest because of inertia. Because of inertia. Right? Like that, there are so many examples are there. So many examples. Suppose in cricket, when a bowler is bowling, what will do? He can bowl from the crease itself, from umpire only. But why will it take some running? Because the bowler is at rest first. To come to motion, to give some speed, he should run from some state. Suppose in a running bus is moving. When you jump from the bus, you cannot stop immediately. You have to run for some more distance to keep your body, to increase the body's ability to stop because of inertia. Similarly, when you are taking the turn, suppose you are going by two-wheeler, four-wheeler, or a cycle. When you want to take the turn, what you have to do? You have to apply some force to take the turn. You cannot simply stand like that to take the turn. You have to apply the force. So that is called inertia of direction. So this property of a body, this inability of the body or the tendency of the body can comes into play when a body is from rest to motion, is called inertia of rest. Motion to rest, called inertia of motion, or change of direction is called inertia of direction. So there are three types of inertia. It can be inertia of rest, inertia of motion, and inertia of direction, where Newton's first law is applicable. Newton's first law is applicable. So you can write down types of inertias. Types of inertia: first, inertia of rest, inertia of motion, inertia of direction. Note down in notebook as a point number 5. And examples you can go through from material. Or so many examples are there, you can see. You can practically also you can experience. When you are going by cycle, if you apply sudden brake, you'll fall front. Correct or not? So everything, because our body is not allowing us to change the position, state of position from rest to motion or motion to rest or to change the direction. All these are studied by Newton's first law of motion. It is also called law of inertia. What called Newton's first law? You can write a sixth point also. Point numbers, after writing these 3 points, you can write sixth point. Newton's first law is also called Newton's first law. Right? First law is also known as law of inertia. What? Law of inertia. So which completely explains about the inertia. All the 3 types of inertias can be seen in our day-to-day life in a simple examples. Suppose your carpet is there, doormat. There are a lot of sand inside. But until unless you jerk, it won't come out. You have to give a jerk. So many examples you can come across in our day-to-day life regarding the inertia of rest, inertia of motion, or inertia of direction. Right? So purely the laws of motion is directly connected to our day-to-day life, day-to-day activities. Right? So totally we learned 6 points today in total entire Newton's first law. So after that, we'll go for Newton's second law and Newton's third law in the next class. But before that, when you recall them, Newton's law, as according to Newton's law, first law, every body is continues to be in the state of rest or uniform motion until an external force is applied. Until an external force is applied. And that property, that inherent property of a body to cannot change its position or cannot change its state of rest or motion is called inertia. Hence, the Newton's first law is also called as law of inertia. What is called? Law of inertia. So, inertia can be either inertia at rest, inertia of motion, or inertia of direction. With many number of examples are given in your material, you can go through them. You spend 5 minutes of time to go through all the examples which are commonly observed. Right? So hope you are clear about the Newton's first law. So we'll move to the next one. We'll go through in the next class about the Newton's second law, and many more are there. Newton's second law of motion, synopsis 2, with many examples and derivation of formula, very important formula, followed by the most important Newton's third law. Right? So we'll discuss the next classes. So when you come here, you can discuss about the exam. So today's work, all this is the homework part where right. So state and explain Newton's first law. First law of motion. Right? So today's work is state and explain Newton's first law of motion. Write down the work. Already you might have copied, you might have written and the synopsis. The same thing, mention in your notebook neatly and take the signature from your parents and as well as from your teachers. Right? So state and explain Newton's first law of motion. Total all the 6 points. So covered here. Right? So thank you very much, students. Have a wonderful day. See you in the next class.